Hi, my name is Justin Riley, and I'm a developer for the Software Tools for Academics and Researchers group at MIT. Today I'll be giving a brief demo on using StarCluster to start your own HPC cluster on Amazon's Elastic Compute Cloud from start to finish. The first step is to install the software. StarCluster is written in Python and can be installed using Python's easy install command. Running easy install StarCluster will download the software along with its dependencies and install StarCluster. Once the software has been installed, the next step is to create the configuration file. Running StarCluster help for the first time will prompt you to create a configuration file. Since we don't have a configuration file yet, we choose the second menu option. This will create an example config file in the default location. Once the config file has been created, the next step is to put our Amazon Web Services credentials and key pair information into the config. In the config, there's a section called AWS Info for entering your access key ID, secret access key, and user ID from your Amazon Web Services account. Once these settings have been entered, the next thing to do is to configure your Amazon EC2 key pair for use with StarCluster. StarCluster uses your EC2 key pair to configure your instances remotely via SSH. In the config, you will notice a key section called GSG key pair. Change GSG key pair to the name of your EC2 key pair. Within the key section, you also need to configure the key location setting to point to the location of the private key that corresponds to your EC2 key pair. Next, we configure the cluster template in the config. A cluster template defines a group of settings that can be used to create a new cluster on EC2. The example config already defines a template called small cluster that defines a small 2-node cluster that uses the 32-bit AMI and the smallest, cheapest instance type available, called M1 small. This template will also create a user called sgadmin on the cluster, as defined by the cluster user setting. StarCluster also supports creating multiple cluster templates, which allows you to maintain multiple configuration settings that can be used when creating new clusters. And in order to avoid specifying which template to use every time, we can specify a default cluster template in the global section of the config to be used by StarCluster when no template option is given at the command line. The default template is defined in the global section by the default template setting and should already be set to small cluster in the example config, as we can see. Now, to use the example small cluster template, we simply need to specify our key pair's name in the template's key name setting. For the purpose of this demo, we'll stick with the example small cluster settings. However, if we wanted to create a bigger cluster, we can increase the cluster size setting to a larger number, change the instance type setting to one of the high CPU instance types, and use the 64-bit StarCluster machine image instead. Now that we've created the configuration file and specified our credentials, it's time to start a small cluster. To start a cluster, we use StarCluster's start command. This command requires us to give a name for the cluster, such as my first cluster. The name we give will be used later to log into the cluster and to terminate it when we're no longer using it. The start command will attempt to use the default cluster template defined in the config, which for the example config is small cluster. Running the start command and providing my first cluster as an argument will now create a new cluster named my first cluster on EC2. If we wanted to start another cluster using the same settings, we would simply run the start command a second time with a different cluster name. During the startup process, StarCluster first validates that all of our settings in the template are likely to produce a working configuration before ever requesting any resources, and then moves on to creating a cluster based on the settings in the small cluster template. The start command will wait until all instances are in a running state and will then move on to configuring each machine in that cluster. This includes creating a new user called sgadmin and configuring passwordless SSH access to each machine for that user. The start command will also NFS share the home directory to all machines and configure OpenMPI and the SunGrid Engine queuing system for running distributed and parallel tasks. Please be aware that this process might take anywhere from 5 to 10 minutes, or longer depending on the current load of Amazon's infrastructure and the number of machines you're requesting. We've shortened this portion of the demo in the interest of time. Once the cluster has been started, we can now log into the master machine by providing the cluster's name to the SSH master command. This command will log you into the master machine via SSH as root and allow you to interact with the cluster to install software, download data, and submit jobs. We can also log in as the cluster user specified in the config by providing the user option to the SSH master command. Now that we're logged in as the cluster user, let's verify that we can execute commands on each machine using SSH without a password. In this example, we verified that running the hostname command over SSH on node 1 returns the machine's hostname without prompting for a password. Also, notice how each machine has been aliased as master, node 1, and so on for convenience. We can also check that the home folder has been NFS shared by creating a file on the master and then verifying that it shows up on node 1 as well. Next, we verify that the SunGrid Engine queuing system has been configured correctly by using the queuehost command and checking that all nodes are listed in the output. Here we see that we have 2 nodes in the queuing system. Now that we know that all nodes are accounted for, let's try submitting a few example jobs that simply print out the hostname of the currently executing node. From the job output, we can see that each job was distributed across the cluster. Now that we've logged in and submitted a few jobs, let's shut down the cluster and stop paying for it. To do this, we first log out of the cluster. Now we would run the stop command, providing the name of the cluster we wish to stop. However, for the sake of discussion, let's assume we forgot the name we gave to our cluster. In this case, we would run the list clusters command to list all the clusters we've started in the past and that are active. Here we see that we named our cluster my first cluster. Now that we remember what we named it, let's stop my first cluster. Once the stop command completes, all machines in the cluster will be shutting down and eventually be terminated, at which point we will no longer be paying to use them. This concludes the demo. To learn more about StarCluster, such as the ability to use elastic block storage devices for persistent storage, please visit StarCluster's website at http://web.mit.edu/starcluster. Thanks for listening.